Alright, now in this lecture we are going to look at traversal of single linked list. So what does the traversal mean? It means we are visiting each node one by one until the end of this single linked list. So let's say we have a single linked list like this, and if you want to traverse through this single linked list, the idea is very simple. We start from the first node, which is node 1, in which we have value of 1, and keep visiting all nodes until we reach the last node. Basically, the logic is like this. So as you see over here, first we are visiting the first node over here, then printing out the value of this first node. So in this case, it's going to print out to the console 1. Then we are going to continue to the next node. So in the next node, we have a node with the value of 2. Then it's going to print out this value. Then based on the reference to the next node, we are going to continue to the next node, which is the node 4. So we are printing out 4 over here. Then based on the next reference, we are going to continue to the last node. So this traversal continues until all nodes are finished. So when we reach the last node, in which the next reference is null, then in this case we are going to terminate our traversal over here. So as you see, the idea is very simple in case of traversal. So let's see how the algorithm of this traversal operation looks like. So in this case, algorithm will start from here. So the first thing that we are going to do, we are going to check that if head is equal to null or not. So if head is equal to null, it means that our single linked list does not exist. So this means that we cannot continue to traverse the elements because we don't have any element in our single linked list. So we will terminate our algorithm over here. So as you see, if head is not exist, so it will continue to the termination. Otherwise, if we have a value in the head, then in this case, we will loop all nodes and printing out the values of node to the console. Then after finishing all nodes, when we reach the node in which the next reference is null, then in this case, we are going to terminate our algorithm over here. So based on this logic, let's implement single linked list traversal in Java. So one more time, inside this single linked list class, we are going to create our traversal method. So the reason why I'm putting all methods this class over here, because with this, when we are creating our single linked list using this class, all methods becomes accessible just writing the name of single linked list and dot. So I'm going to implement our method after this insertion method that we created over here. So here I have commented single linked list traversal, so I'm going to create our method over here. So the method will be like this, public void. So this method will not return anything, that's why I put void over here. So the name of method will be traverse single linked list. So this method will not take any parameter because we are going to visit all elements of the linked list that we created over here. So the first thing that I'm going to do, I will check that if head equals to null, then in this case it means that the single linked list does not exist. So I'm going to print out to the console saying that the single linked list does not exist. Then in the else condition, we are going to visit our elements one by one and printing out to the console. So as you remember, we have created size property over here. And each time whenever we are inserting a new element, we are increasing the size of this single linked list. So this means that in this size property, we will have the number of elements of the single linked list. So if we loop until this size, from 0 to this size, so it means that we are going to visit all nodes of single linked list. So here inside else condition, the first thing that I'm going to do, I need to start from the head. So that's why I'm going to create a new node, which will be the temp node. And this will be assigned the value of head because we are starting from the head. Then inside this loop for I starts from 0 until we reach the size of this single linked list. This is the size that comes from the property. And this will be increased by 1 every time. So then inside this loop, what I'm going to do, I'm going to print out temporary node's value. So system out print, it's going to print out temp nodes dot value. So every time we are accessing the value of the node that we are visiting. So here to print out our single linked list as a proper single linked list, I am going to write if condition like this. So if I is not equal to the size, which means that if we have not finished the visiting of all nodes, then in this case, I'm going to print out to the console this arrow over here. So with this, we are going to put an arrow between nodes. So then after doing so, the next thing that we are going to do, we have to visit to the next node. So this means that temp node will be set to temp.next because each time we are visiting the next node. So in each iteration, we are going to assign this temp node the next reference of this temp node over here. So this means that it will continue to the next node until we have reached the size of this single linked list over here. Then at the end, after this if condition, I'm going to print out to the console just new line character to make our life easier. So if you put something and so it's going to bring our cursor after this print statement over here. So we will have a one line space after the print statement. So with this we have finished our traversal method. So basically what we are doing over here, using size of single linked list, we are visiting all elements of single linked list, and in each iteration we are going to the next node and visiting that node's value. So with this print statement if condition over here, we are putting an arrow between the nodes that we are going to print out. So let's see how this is working in practice. So what I'm going to do over here, I'm going to just comment these print statements over here and insert few nodes to our single linked list. So in this case, I'm going to insert one more node, for example, with the index of 4 with 8. Then let me just insert one more node over here. So with the index of 5, for example, it's going to be 9. Then after insertion, I'm going to call our traversal method. So traverse, so the method name is traverse single linked list. So I'm going to put it over here, and then I'm going to run our code. So when we run our code, you see that our single linked list is printed out to the console. So our first element is 5. So first we are visiting 5, then the next element is 6, then we are visiting 6, then the next element is 7, then we are visiting 7, then the next element is 8, then we are visiting 8, then the last element is 9, then we are visiting 9. So instead of 5 over here, if I put 0, it's going to insert this 9 at the beginning of this single linked list. So this means that first we have to visit this node. So in this case, if I run our code, first we have to visit 9 from here. So you see that in this case 9 is the last one, but in this case 9 should be the first one. So after running, you see that first we are visiting 9, then 5, then 6, then 7, then 8. So this means that we are starting from the first node and we are continuing until we have reached to the last node. So in this case, 8 is the last node of this single linked list. Now let's see what's the time and space complexity for this method over here. So as always, we are going to start from the first line of code of this method. So in the first line, we have if condition in which we are checking that if head is equal to null or not. So if it is equal to null, we are printing out to the console that single linked list does not exist. So this means that this print statement inside this if condition will take O one time complexity. So this if condition will take O one time complexity. Now in the else condition, we have created a new node, temp node, and assigned head value to this temp node over here. So this line of code also will take O one time complexity because this is just a simple assignment statement. Then in the loop, we are looping through the nodes until we reach the size of this single linked list. So if the size of single linked list is n, so this loop over here will take O n time complexity. Now inside this loop, we are printing out the node value to the console, which will take O one time complexity. Then we are printing out this arrow to the console based on this if condition over here, and this if condition also will take O one time complexity. Then at the end, we are setting temp node's next value. So this means that we are going to the next node. So this is also an assignment statement. So this will also take O one time complexity. Then at the end, we are printing out new line to the console, and this will also take O one time complexity. So basically we have put this new line over here to make our code readable. So as you see, after printing out our nodes, it's giving us new line over here. So that's why this new line also will take O one time complexity. Now if we combine all these complexities over here, we will get O n time complexity, because O one time complexities over here are non-dominant terms, so we can easily eliminate them. So we have only left with the O n time complexity. So the traversing a single linked list will take O n time complexity, where n is the number of nodes in the single linked list. Now the space complexity will be O1, because in this case an extra memory is not required to traverse these elements in single linked list. So that's why space complexity will be O1. So with this, we have come to the end of this lecture. So in this lecture, we have explained how can we traverse through a single linked list, and we have implemented using Java programming language. So hopefully everything is clear about traversing single linked list.